Hello everyone, welcome to Rising Cousins. I am Syed Quazi and today we are going to continue chemistry chapter of metals and non-metals of class 8. This is our fourth lecture and this is the chemical properties part 3rd, and in the MCQs version this lecture can be found in the link in the description box below. Our MCQs will help you see if the concept taught in this video has been understood properly by you or not. So I recommend that you check them out, try to answer them. We will make a video of 2 MCQ sets in a video. We'll explain that fully. Let's see what we have learned till now before we head on into the main topic of the video. Elements can be divided into 3 types: metals and non-metals, and metalloids. Metals, non-metals, and metalloids. Elements are classified into these types using their physical and chemical properties. Although physical properties have many exceptions, chemical properties do not. Okay, there maybe are a few. Metals and non-metals are mostly divided that have the tendency to electrons. Metals have a tendency to give electrons, while non-metals have a tendency to take electrons. Let's see what we are going to learn today. So today we are going to learn the reactions of metals and non-metals with acids and bases, the reactivity series of metals, displacement reactions, and corrosion of metals. Let's see the reaction of metals with acids, metals and non-metals. Okay, so when a metal reacts with acid, a salt and a hydrogen gas is produced. This is the base reaction of it. So if this is the base reaction. If a metal is mixed with an acid, metal plus acid, it will give a salt and hydrogen gas. So what about non-metals? Non-metals generally do not react with acid. So let's see the examples of metals reacting with an acid. So sodium is a metal, as you may know, and sodium when it reacts with sulfuric acid forms sodium sulfate and hydrogen gas. So when sodium is added to sulfuric acid, it forms sodium sulfate and hydrogen gas. So there's another example of zinc reacting with sulfuric acid. It is this. So it can be done in equation form like this: Zn plus H2SO4 gives ZnSO4 plus H2. So let's see an example of a metal reacting with acid so you can learn it better. So this video is of class K class science channel, and he does many scientific videos, so you can go check him out. I am leaving this video's link in the description box below, so you can go and check that out as well. So let's start.
Granules, which are metals, dilute hydrochloric acid and dilute sulfuric acid, and a match granules. We will put zinc granules in both.
So what he is doing here is that he is adding zinc granules in hydrochloric acid and sulfuric acid. So let's see what happens here.
Put zinc.
Let me turn up the sound a little bit. Oh, it's full. So I think the video's sound is like that.
Granules in both the beakers. You will observe that zinc reacts with acids and releases a gas. What is the gas?
As you can see, this should be hydrogen gas, and as we saw in the last slide, let me show that to you here. Let's see. See, there's H2 right here, so that gas was H2.
Observe that zinc reacts with acids and releases a gas. What is the gas which is formed? Take the beaker containing dilute hydrochloric acid, light a matchstick and introduce it into the gas near the mouth of the beaker.
Oh, so this is a characteristic of hydrogen. So when you try to burn a matchstick or something, it will produce a pop sound, and we will also see this type of check to see if it's hydrogen or not in the video, where we see some more reactions.
You see that the match.
As you may have heard properly, or I don't know if the voice is coming properly or not in the video, but so you can go, if you can't hear, go in the video's description and get this video's link and listen to the sound properly. As you can see, it would make a popping kind of sound, like pop like sound. So that means that the gas released is hydrogen. So let's go on into the video.
The pop sound when brought near the open the beakers. Let's try it again. Take the beaker containing dilute sulfuric acid.
So this time, instead of in the hydrochloric acid mixture, it is going to add in the sulfuric acid mixture.
Again, test the gas formed using a lit matchstick. Listen carefully for the sound.
Yeah, so it is giving the same sound as before. That means here also hydrogen gas is being produced. Let's go into the reaction of metals with bases. So only certain metals react with acids. Metals like zinc, aluminum and lead react with strong bases like sodium hydroxide. So not every metal will react with a base. So yeah, so when these metals react, they produce a compound of that metal and hydrogen gas. So the example would be 2Al plus 2NaOH gives 3A, NaLO2 plus 3H2. More complex than the reaction that we have seen till now, but yeah, let's go into the a video explaining the reaction of metals with bases. So this is of CS31 School and Teacher Education. Yeah, so you can go check out the video in the link in the description box below as well. I have made the video in 2x because if I had not, it would have been like 1 or 2 minutes long. 2 minutes long, like, yeah, 2 minutes long. So I have made it 2x so I don't bore you that much. The video as that would be big. So she or he is adding water pellets, sodium hydroxide pellets into water to make them NaOH, that means sodium hydroxide. So let's see, yeah, so she is adding water into it to make it sodium hydroxide. Now she is mixing it. Shake it well. Yeah. So now she is adding the aluminum foil in it. Yeah. Now she should mix it. Yeah. Now she will show you the hydrogen gas pop sound. Yeah. Now that was a lot bigger than the K class video. Let's see it again. So let's see another pop sound. Yeah, so that means it is really hydrogen in there and not nothing else. So let's go into the reactivity series of metals. So this is a lot different that we have done till now, or more complex. So yeah, so this series gives a series of metals which aligns them by least reactive or most reactive. As you can see, potassium is the most reactive metal and platinum is the least reactive. You can learn this table. There are many mnemonics out there in the internet. You can check them out. There are many, but I have learned them. I think, yeah, let's check it out. Potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. Was I right? Yeah, looks like it. So this will help you in every many equations. So like when a teacher asks you between any of these, you should know like more, like potassium is at the top side, so it is most reactive. So like magnesium will be more reactive than iron, zinc will be more reactive than tin will be more reactive than gold, copper is more reactive than silver, and so on. So teacher can ask any combination, so be sure to learn this table. So if I were Wikipedia, I would have written this definition. So the arrangement of metals in a vertical column in the order of decreasing reactivities is called reactivity series of metals. So let's see a equation based on the reactive series of metals. So they are the displacement reactions. So those reactions in which a more reactive element displaces another less reactive element from its compound is known as displacement reaction. So let's see the examples of them. Iron reacts with CuSO4 to form FeSO4. This is the picture of iron reacting with copper sulfate. This is the reaction. Fe plus CuSO4 gives FeSO4 plus Cu. As we have seen in the last table, iron is more reactive than copper. So what it did was it took out copper from its compound and replaced its place. So yeah, as you can see, copper is out now and iron has gone into it. So let's see magnesium reacting with FeSO4 to form MgSO4 plus and Fe. Magnesium Mg plus FeSO4 gives MgSO4 plus Fe. Let's see, yeah. Magnesium is here, iron is here. So that means magnesium will replace iron. So the further these two elements are apart, the faster the reaction will be. So let's see a reaction in which a less reactive metal tries to react with a metal with more reactivity. So Cu tries to react with MgSO4 solution but gets no reaction. That's kind of sad. Yeah. Let's see an example of Fe plus CuSO4 plus FeSO4 plus Cu. That this is the most common example that you will get. This is also from K class plus, so you can also check this video out in the description box below.
Copper sulfate, iron nails, water. Dissolve 2 spoons of copper sulfate in some water.
So he is adding copper sulfate into water. So this is copper sulfate solution. So he can dip the iron nails into it. It is more easy than using a solid version of it.
Now place 2 bright soft iron nails into the solution and observe. The nails soon turn reddish brown while the solution turns.
What does copper look like? What is copper's color? It is slightly reddish brown. Reddish, right? Yeah. So what is copper doing here? Iron and copper are doing here is that the iron from the nails is dissolving, is taking the place of copper from the liquid solution, and the copper that has been displaced is now settling on top of the iron nails as it has nowhere to go.
After a while, what happened was the iron from the nails replaced the copper sulfate solution and formed iron sulfate, and the displaced copper precipitated out and settled on the iron. The nails there.
This is a very common example of displacement reaction, and you will find this in exams and tests.
Or change the color of copper while the.
This I think was also in 6th or 7th standard in acid and bases. I think so. I don't remember properly.
Solution show.
I wasn't very attentive with 7th.
The characteristic green color of ferrous sulfate. A reaction of this type is called a single displacement reaction. CuSO4 plus Fe gives FeSO4.
So he concludes with a correct statement, which is CuSO4 plus Fe gives FeSO4 plus Cu. Yeah. So let's see corrosion. As you all may have seen, you all may have seen rusted iron nails and chains everywhere lying around because they are not useful anymore and they clearly do not look very attractive. This is a picture of a rusted iron chain. As you can see, does not look like iron anymore, and very ugly reddish fungus like thing has grown on it. However, that is not fungus, don't get confused. There can be algae growing on it, but this reddish thing is not a fungi or anything. So this is also an example of corrosion. First, if you were born when the Statue of Liberty was gifted to America, New York, then you may have seen this Statue of Liberty. But now it looks like this. Copper corrodes, iron corrodes. This looks more beautiful than this. I would have liked this more than this. So yeah, let's see the definition of corrosion in respect to Wikipedia. Get to Wikipedia. Corrosion is a natural process that converts a refined metal into a more chemically stable form, such as oxide, hydroxide, or sulfide. It is the gradual destruction of metals by chemical and or electrochemical reaction with the environment. My God. It is more impacting than ever destruction of elements. Chemical or hydrochemical reaction. Very complex definition, but just need the basic understanding of it. You don't need to learn this big dangerous definition. So let's see the rusting of metal. So when iron reacts with the oxygen and moisture present in the air to form brown flaky substance called rust. I thought it was red. It looks kind of red though. Yeah. So this is a reaction complex than ever. F4Fe plus 3H3O2 gives 2XH2O gives 2Fe2O3.XH2O. This X means that we don't know how much water is involved, so we just add X into it. Variables. So let's see the corrosion of copper, and I warn you, same problem with the definition. Copper object get coated with a green substance called basic copper carbonate with the passage of time. Reveal 2Cu plus O2 plus CO2 plus H2O gives CuOH twice dot CuCO3. Here 2 means that there are two here. It's in subtitles, but to save time or something, I don't know the reason, they just put it in brackets and write 2 there. So it's like the distributive property of, so it would be, if we had wanted to write it, it would be CuO2 H2.CuCO3. I like this bracket from better. I don't know why. Maybe because I am a nerd. So yeah, thank you. This will be the end of our lecture. So please make sure to like, share and subscribe to our channel, so we have the encouragement to going on.